This is SpaceTime, Series 27, Episode 117, for broadcast on the 27th of September 2024. Coming up on SpaceTime, the biggest black hole jets ever seen, NASA's Europa Clipper mission ready for launch to the Jovian ice moon, and Iran tests another nuclear-capable missile in defiance of United Nations resolutions. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected the biggest pair of black hole jets ever seen, spanning an incredible 23 million light-years. That's the equivalent of lining up 140 Milky Way galaxies end-to-end. A report in the journal Nature claims this jet megastructure, which has been named Porphyron after a giant in Greek mythology, dates back to a time when the universe was just 6.3 billion years old, less than half its current 13.8 billion year age. The study's lead author, Martin Oey from Caltech, says the fierce outflows, with a total power output equivalent to trillions of suns, shoots out from above and below a supermassive black hole at the heart of a remote galaxy. Prior to Porphyron's discovery, the largest confirmed black hole jet system was Alcyoneus, also named after a giant in Greek mythology. Alcyoneus, discovered in 2022 by the same team that found Porphyron, spans the equivalent of around 100 Milky Way galaxies. Now, for a comparison, the well-known and studied Centaurus A jets, the closest major jet system to Earth, spans about 10 Milky Way galaxies. These latest findings suggest that these giant jet systems may have had a larger influence on the formation of galaxies in the younger universe than previously thought. Porphyron existed during an early epoch when the wispy filaments that connect and feed galaxies, known as the cosmic web, were closer together than what they are now. That means enormous jets like Porphyron reached across a far greater portion of the cosmic web compared to jets in the local universe today. Astronomers believe that galaxies and their central supermassive black holes co-evolve, and one key aspect of this is that the jets can spread huge amounts of energy which affect the growth of both the host galaxies as well as other galaxies nearby. But this new discovery clearly shows these effects can extend much further out than previously thought. The Porphyron jet system's the biggest found so far during a sky survey that's already revealed a shocking number of these faint megastructures, more than 10,000. This massive population of gargantuan jets was found using Europe's LOFAR, low-frequency array radio telescope. While hundreds of large jet systems were already known before the LOFAR observations, they were thought to be fairly rare and on average smaller in size than the thousands of systems uncovered by the study. Giant jets were already well known before the authors began this campaign, but they had no idea that there would turn out to be so many. Back in 2018, the authors began using LOFAR not to study black hole jets, but the filaments of galaxies, galaxy clusters and superclusters that crisscross the cosmos and border the vast empty voids that make up the cosmic web-like structure of the universe. As the team were inspecting the radio images of these faint filaments, they began to notice several strikingly long jet systems. Oey says when he first found the giant jets, he was quite surprised because he had no idea there'd be so many. To systematically search for more hidden jets, the authors inspected the radio images by eye, and they used machine learning tools to scan the images for signs of looming jets. A separate paper describing the most recent batch of giant outflows containing more than 8,000 jet pairs has already been reported in the journal Astronomy and Astrophysics. To find the galaxy from which Porphyron originated, the team used the giant meter wave radio telescope in India, along with ancillary data from the dark energy spectroscopic instrument DESI at the Kitt Peak National Observatory in Arizona. The observations pinpointed the home of these jets to a hefty galaxy about 10 times more massive than our Milky Way. The authors then used the Keck Observatory in Hawaii to show that Porphyron is some 7.5 billion light-years from Earth. Oey says that up until now, these giant jet systems appear to be a phenomenon of the recent universe. But if distant jets like these can reach this scale across the cosmic web, then every place in the universe may have been affected by black hole activity at some point in cosmic time. The observations from Keck also revealed that Porphyron emerged from what is called a radiative mode active black hole, as opposed to one that's in a jet mode state. Now, when supermassive black holes become active, in other words, when their immense gravitational forces start tugging on and heating up surrounding material, they're thought to either emit energy in the form of radiation or jets. Radiative mode black holes were more common in the young or distant universe, while jet modes are more common in the modern-day, present-day universe. The fact that Porphyron came from a radiative mode black hole came as somewhat of a surprise for the astronomers, because they didn't know this mode could produce such huge powerful jets. What's more, because Porphyron lies in the distant universe, where radiative mode black holes abound, the finding implies there's got to be lots more colossal jets like this left to be discovered. He thinks we may be looking at just the tip of the iceberg. The LOFAR survey has so far only covered about 15% of the sky, and most of these giant jets are likely to be difficult to spot, so there are likely to be many more of these behemoths out there. Exactly how these massive jets can extend so far beyond their host galaxies without destabilizing is still unclear. See, there isn't anything particularly special about the environments of these giant sources that would cause them to reach these huge scales. So the authors are speculating that you'd need an unusually long-lived and stable accretion disk around a black hole to allow it to be active for so long, we're talking about 1 billion years here, to ensure that the jets keep pointing in the same direction over all that time. What astronomers are learning from the large number of these jets is that it must have been a relatively common occurrence. As for the next step, OE wants to better understand exactly how these megastructures are influencing their surroundings. These jets are spreading cosmic rays, heat, heavy atoms and magnetic fields throughout the space between galaxies. And that could be both triggering more starburst formation and also blowing material out of galaxies, turning them red and dead. This is SpaceTime. Still to come, NASA's Europa Clipper mission, ready for next month's launch to the Jovian ice moon. And Iran tests another nuclear-capable missile in defiance of United Nations resolutions. All that and more still to come on SpaceTime. All systems are now go for next month's launch of NASA's Europa Clipper mission to study the oceans of the Jovian ice moon Europa. Selected for launch from the Kennedy Space Center in Florida on October 10 aboard a SpaceX Falcon Heavy, comprising 3 Falcon 9 rockets mounted side by side, Europa Clipper will be the first NASA spacecraft dedicated to studying an ocean world beyond Earth. Its primary mission is to discover whether the global liquid water ocean beneath Europa's icy crust could be habitable. The 6,000-kilogram Europa Clipper is the largest spacecraft ever built for a NASA planetary mission. The vehicle extends some 30.5 metres from one end to the other, and it's about 17.6 metres across. That's bigger than a basketball court, thanks in large part to its huge solar arrays. They need to be huge so they can collect enough sunlight while near Jupiter to power the spacecraft's instruments, electronics and other subsystems. It'll take 5.5 years to travel the 2.9 billion kilometres to the Jovian ice moon. Europa Clipper will then spend a further 4 years studying the 3,120-kilometre-wide Galilean moon, undertaking a series of 49 close flybys, specially designed to avoid as much of Jupiter's dangerous radioactive belts as possible. See, Jupiter is surrounded by a giant magnetic field some 20,000 times stronger than the Earth's. As this field spins through space, it captures and accelerates charged particles, generating radiation that can damage spacecraft. So mission managers designed Europa Clipper with a special vault to shield its most sensitive electronics from this radiation. And they plotted orbits that will limit the amount of time Europa Clipper spends in the most heavily radiated areas around Jupiter. On each highly elliptical orbit, the spacecraft will spend less than an Earth day in Jupiter's dangerous radiation zone near Europa before being flung back out. Then 2 to 3 weeks later, it'll repeat the process, making another close flyby. Data from previous NASA missions, including the twin Voyager spacecraft in the 1980s, the Galileo mission in the 1990s, and the current Juno mission still orbiting Jupiter, have all provided scientists with strong evidence that Europa's salty liquid water ocean contains minerals which could have infused into the water from deep ocean vents on the seafloor. That would be very similar to the mid-ocean ridges on Earth, which teem with unique life forms not seen anywhere else on the planet, and which many scientists speculate could have been where life on Earth first began. If we find that the same thing happened on Europa, it would mean two independent regions of space where life has spontaneously evolved. And that would suggest that life is common throughout the universe. The European Space Agency's Jupiter Icy Moons Explorer or JUICE spacecraft, which was launched in April last year, is already on its way to the Jovian system. Its primary mission is to study Ganymede, but it will also inspect Callisto and Europa. In fact, it will undertake two close flybys of Europa, providing complementary data to the NASA mission. Scientists believe that Europa is one of the most promising places to look for currently habitable conditions beyond Earth. There's scientific evidence that the ingredients of life, water, the right chemistry, and energy may all exist on Europa right now. And Europa Clipper will garner the information scientists need to find out for sure. Europa's subsurface ocean holds twice the amount of water of all of Earth's oceans combined, and it may also host organic compounds and energy sources under its surface. If the mission determines Europa is habitable, it would mean there's more than one habitable world in our solar system. To determine if Europa is habitable, Europa Clipper must first determine the thickness of the Moon's icy crust, as well as its interactions with the ocean below, and then assess the Moon's interior, its composition, and its geology. To do this, the spacecraft carries 9 scientific instruments, as well as a gravity experiment using the telecommunications system. In order to obtain the best science data during each flyby, all the spacecraft's science instruments will need to operate simultaneously on every pass. Mission managers will then be able to layer the data together in order to paint a fuller picture of the Moon. Jupiter is on average about 770 million kilometres from Earth. With both planets in motion, they're often at opposite ends of their orbits to each other. But the Europa Clipper spacecraft itself can only carry a limited amount of fuel. So mission planners are instead sending Europa Clipper past Mars and then past the Earth, using both planets' gravity as a sort of slingshot to add speed to the spacecraft's trek. After journeying some 2.9 billion kilometres over the next 5.5 years, the spacecraft will fire its engines in order to achieve orbit insertion around Jupiter in 2030. More from NASA TV.
The most exciting thing about Europa can be summarized in one word: water. Now think about all the water on Earth, and double that. That's what we think is on Europa.
We need to go there to explore it, to understand, is this place a habitable environment that could potentially support life?
Getting close to Europa is a huge challenge. It sits in the worst possible radiation environment, trapped by Jupiter.
Europa is a moon of Jupiter, about the size of Earth's moon, which has an icy surface that probably hides a subsurface ocean.
Scientists think Europa has the key ingredients to support life as we know it. Number 1, water. Number 2, energy. And 3, essential chemical building blocks. For the first time ever, we're sending a spacecraft completely dedicated to studying this moon.
The 3 main things that we're going to explore at Europa are the ice and ocean and understand that intersection between the two, study the chemical composition of the moon, as well as the geology and whether it's active currently.
Europa Clipper is not specifically a life search mission. We're going to understand the potential habitability of Europa. The spacecraft has 9 instruments and a gravity science investigation. 5 of the instruments are called remote sensing instruments because they measure light reflected off Europa, like a camera or a spectrometer. The other 4 instruments are measuring the environment around them, like sniffing gases or dust.
Europa Clipper is the largest spacecraft NASA has ever built for a planetary mission.
It weighs 13,000 pounds, 6.5 tons. That's like the size of a huge African elephant.
And the solar arrays are massive. If you put the solar arrays at the toes of the Statue of Liberty, the other end of the arrays would come up to the Statue of Liberty's crown.
So not only are they big, these things are technological marvels. They are being bathed in radiation all the time, and they have to survive the entire mission like that.
Jupiter's radiation environment is intense. and Europa sits in the worst part of that environment.
Jupiter acts like a giant particle accelerator. There are charged particles trapped in Jupiter's magnetosphere that rotate with it. And these particles slam against Europa and will slam into our spacecraft as well.
We protect the spacecraft in two ways. Number one, we try to minimize the amount of time we spend in there, which is why we are orbiting Jupiter and just flying by Europa. The second way we protect against the radiation is by having an electronics vault that we put our computer and some of the other sensitive electronics inside, which is made of about 1/3 of an inch of aluminum.
With each flyby of Europa, the outside surface of the spacecraft sees the equivalent of 1 million chest X-rays, just as we're flying by.
It's a pretty long trip to get to Jupiter from Earth, but not that bad from a planetary standpoint.
From launch to the time we get to Jupiter is about 5.5 years. And along the way, we have a flyby of Mars and then another flyby of Earth to get gravity assists to slingshot the spacecraft out to Jupiter.
I hope for the future explorers who are watching this at home that they take away from this that humanity, when we come together, can achieve really cool things.
This mission has been a long time coming, and we're so excited about what we're going to see when we get there.
We are in a golden age of robotic spaceflight exploration. How could you not be excited about something as monumental as this?
I am most excited about the potential to unlock the secrets of Europa, the potential to really understand this crazy world that exists and has likely existed in this condition for 4 billion years.
And in that report from NASA TV, we heard from Europa Clipper project scientist Robert Papalaro, Europa Clipper Launch to Mars mission manager Tracy Drain, Europa Clipper project manager Jordan Evans, and Europa Clipper telecom system engineer Deepak Spinavasan. This is SpaceTime. Still to come, Iran tests another nuclear-capable missile in direct defiance of United Nations resolutions. And later in the science report, the surprising discovery of a decline in the consumption of alcohol among today's young people. All that and more still to come on SpaceTime. Iran has launched another medium-range ballistic missile into orbit as it continues to perfect its planned nuclear weapons delivery system. The launch, which defies UN Security Council resolutions, was undertaken using a Karam-100 missile. The Karam-100 is Tehran's first 3-stage solid-fueled missile. It can carry twice the payload of its predecessor, the Qasid, without any increase in missile mass. The Qaram's first stage uses gimbaled thruster vector control for steering and has an advanced carbon fiber composite wound casing to reduce the mass. Tehran says the rocket blasted off from a mobile launcher at the Islamic Revolutionary Guard's missile test range 350 kilometers east of the capital. It placed a 60-kilogram Defense Ministry dummy payload into a 550-kilometer high orbit. Iran State Television claims the Chamran-1 satellite, as it's been designated, is designed to test electronic systems for orbital maneuvering technology. The Islamic State, which is the world's largest sponsor of terrorism, has been actively developing nuclear weapons and the means of delivering them, with Israel and the United States listed as its primary targets. Back in January, Tehran launched 3 payloads into space using its Seymour or Safir 2 two-stage liquid-fueled rocket. That's based on the North Korean No-Dong or Hwasong-7 medium-range ballistic missile, which in turn is based on earlier Russian Scud missile technologies. German and Swedish intelligence agencies have warned of growing efforts by Iran to obtain technology needed to build nuclear weapons. The warnings come as the Islamic Republic continues to insist its nuclear activities are for purely peaceful power generation purposes only. The German intelligence agency says Tehran has not ceased its drive to obtain weapons of mass destruction and the products used for their manufacture, as well as corresponding weapons carrier systems. Meanwhile, Sweden's security service says that Tehran's long been seeking Swedish technology for nuclear weapons programs. The security service reported that Iran was conducting industrial espionage, mainly targeting Swedish high-tech industries, which can then be used for nuclear weapons programs. The warnings come in the wake of increased uranium enrichment efforts by the Islamic Republic, which is using ever-increasing cascades of centrifuges in an effort to produce enough weapons-grade uranium for an arsenal of nuclear bombs. This is SpaceTime. And time now for another brief look at some of the other stories making news in science this week with the Science Report. A new study has found a link between polyunsaturated fatty acids during fetal development and autism spectrum disorder in children. Autism is a neurodevelopmental disorder that affects learning capability and social behaviour. Although the exact causes remain unclear, currently available evidence points to neuroinflammation as a major factor. And several studies have hinted at the importance of polyunsaturated fatty acids and their metabolites during pregnancy playing a key role in autism development. Polyunsaturated fatty acid metabolites are regulated by cytochrome P450 or CYP enzymes, and they affect fetal development, causing impairments closely linked to autism spectrum disorder symptoms. To test this hypothesis, the authors investigated the link between polyunsaturated fatty acid metabolites in umbilical cord blood and autism scores in some 200 children. A report in the journal Psychiatry and Clinical Neurosciences analysed neonatal umbilical cord blood samples collected immediately after birth and then preserved for analysis until the kids were 6 years old. The samples were then tested for CYP polyunsaturated fatty acid levels. The authors found dihydroxyincosat acids in cord blood that may have strong implications for autism severity. They found higher levels of the molecule had an impact on social interactions, while lower levels impacted repetitive and restrictive behaviours. And interestingly, this correlation was more specific for females than for males. Scientists have developed a new metasurface-based edge-detecting filter for use in remote sensing of agriculture and crops. The research by the Australian Research Council's Centre of Excellence for Transformative Meta-Optical Systems could pave the way for improvements in environmental monitoring and surveillance systems, as well as augmented reality and biomedical imaging. The research, reported in the journal Nature Communications, realises a new tunable edge-detecting filter for flat optical imaging systems that can switch between an image of an object's outline and a detailed infrared image. The findings could lead to the development of a new generation of ultra-compact, tunable passive devices for all optical computation. When you think back to the stuff you got up to during your teenage years, for many, alcohol played a role somewhere. But a new study has found a decline in the consumption of alcohol among young people, although the reasons remain a mystery. And interestingly, the findings reported in the Drug and Alcohol Review show males were the stronger drivers of this decline. The study suggests that some young people are choosing weed instead of alcohol. But some of the authors are speculating that the decline in drinking could be partially due to increased anxiety and loneliness among young people. The authors say there's still plenty of research to be done to better understand this trend and just how much the role of alcohol in a young person's life has changed. Well, of course, it was only going to be a matter of time before celebrity boy psychic Tyler Henry made it onto Australian skeptics. And it took 80s pop idol Boy George to burst the bubble. Tyler Henry was born as Tyler Henry Calhoun in 1998 in Hanford, California. He claimed he first noticed his clairvoyant capabilities at the age of 10 when he got a premonition of his elderly grandmother's death. Later, he joined the professional paranormal circuit. Tim Mendham from Australian Skeptics says scientific skeptics have long argued that mediumship is a con, and the formula is actually very simple.
Tyler Henry is a young fellow, not quite sure how young he is. Probably not as young as he makes out to be. He's got a baby face, etc., and all this enthusiasm, etc. He's a supposed psychic and a clairvoyant, and he can contact the dead. And he specialises in a TV show, which is very popular apparently, in which he talks to celebrities. And he reveals a lot of information, and the celebrities necessarily start crying. And sort of, how did you no, that it can't be true. You contacted my granny, and she says that she's happy up in heaven, and she still loves me.
Of course, it's all stuff you can Google about the same celebs. Celebs aren't that bright, are they?
Yeah, no, celebrities aren't. I mean, and if anybody's going to put a lot of stuff about themselves online, it's going to be celebrities. Okay, so if Tyler goes around every show, he goes around and visits a different celebrity, often in their homes. And so he turns up at the doorstep of famous pop singer Boy George of the band Culture Club and everything else since, who's been around for a long time. And anyone with an inch, a modicum of knowledge of pop music will know of Boy George. He had some decent songs, actually, so that's not too bad. Up at the door,
Club and Boy George were huge when I was starting out as a radio DJ.
Yeah, absolutely. I like what's in the Clock of the Heart, was it? That's a great song. Anyway, so Tyler turns up at the door of Boy George's home, and Boy says, hello, and Boy asks him, do you know who I am? And Tyler says, no, sorry, I have no idea who you are. Having been told to go to his home and turn up like totally random, and he then starts revealing stuff about Boy George's background and the people he knew and those who were in heaven. And Boy George is going, no, that's not true, no. And Tyler's obviously getting a bit frustrated with this. So you normally hear someone sort of sobbing in front of you within 5 seconds. But George is saying no. Basically, George is playing with him. And in another room, Boy George's manager is watching this thing on closed-circuit TV. And he gets annoyed because the manager's very keen on this stuff, has set up this interview, and he's a believer in these psychic powers and things. And then halfway through the interview, he goes rushing into the room where Boy George and Tyler Henry are and says, you do know someone like this. You do know someone, Ed so-and-so. You're pretending. And Boy George is not too impressed, obviously, by the video of this. And his manager is sort of coming in and making him look like either a fool or a cheat.
Well, I wonder who's been supplying Tyler Henry with the data on Boy George.
You wonder, don't you, about this person who's the manager who believes in this stuff and who has arranged this story with Tyler. And Tyler Henry can just go look up this stuff. I looked it up, and it's all there online, as most of these things are. So it's called hot reading. Hot reading, you do, the psychic, in quotes, does their research beforehand and bones up on a lot of facts about this person, and you can try and work your way through Facebook pages and stuff that's online. Everything's online.
That's Tyler Henry's entire spiel, but isn't it?
It is. And people say he could never have known it. And I've had people who approach me, not necessarily about Tyler Henry and his clients, but about other things, and saying they could never have known this, and they're going to offer money to them, or they're very upset by them. And I say, right, ding, on the phone, looked at your Facebook page, it's all there. And they go, oh. And you think, blimey, Charlie, it's so easy to do. Cold reading is when someone is sort of pitching questions to you. They don't know the answers, and then they try and pick up on little clues that the client says, or gestures, or that sort of thing.
You have a relation whose name starts with a G.
With a G. And what you mean, my grandmother? Yeah, that's the one. And this person says, my grandmother was a lovely lady. Now, I'm getting the feeling your grandmother has died. So
yeah, well, I'm 65. Of course, my grandma's passed on.
Yes, yeah, no, that's cold reading. And basically the psychic just feeds back the things that the client has already told them. Hot reading is even more sinister. And we've had articles, and there's some people in the US, especially Susan Gerby and her late partner Mark Howard, who did stings of these psychics, and they showed how easily it is to get information online, detailed information, supposedly secret and personal information online. People can't help themselves but reveal this stuff, or someone else reveals it on their behalf. So they set up these phony websites and that sort of stuff, and got interviewed by a few famous psychics who then fed back this same information to them, which was totally wrong. It's obvious that the psychic was picking up information online. They'd done their hot reading background. I'm sure Tyler Henry, legal issues aside, I'd be surprised if Tyler Henry did not do something similar. He does his research. Turning up at the doorstep of a famous pop singer and saying, I don't know who you are, is either he's 15 years old and has never listened to music in his life, or he's fibbing. The problem is that halfway through, Boy George sort of gives up, and it looks like the reading is succeeding, because he does get a bit teary over some of the things that...
Well, the manager's obviously talked him into it by then.
But he has talked him into it, yeah. Even though if I was Boy George, I would have sacked the manager on the spot for actually embarrassing Boy George in front of these other people and on TV. But it's actually fascinating to watch, because it is a good example of hot reading.
Yeah.
And you see the psychic's frustration at first when his hot reading is not paying off, and then it eventually does. And of course, Tyler's sort of so totally innocent about all this stuff. Wow, I discovered all these interesting things about you.
That's Tim Mindham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.